Okay, I think one of the question was, what is the significance of isocitrate dehydrogenase, right? Okay. Let me answer that question prematurely for now, but it's okay. It might help you. You see, pyruvate cannot enter mitochondria as pyruvate, so it has to be converted on the mitochondrial membrane to acetyl-CoA. Similarly, acetyl-CoA cannot leave directly out of the mitochondria or come into mitochondria. It can't do that. Okay, so there's a problem. Now, acetyl-CoA is combined with oxaloacetate, correct?
Yeah.
With oxaloacetate, it's combined to make what? Citrate. Citrate can leave mitochondria, no problem. Can come back into mitochondria, no problem. Now, it depends if citrate should be consumed in this reaction to be converted to isocitrate dehydrogenase. Isocitrate, sorry. I'm talking about the enzyme now. So isocitrate, whether citrate leaves mitochondria, okay, or it is consumed by isocitrate dehydrogenase into alpha-ketoglutarate. So it depends, you have two pathways for citrate. It can go this way in the green pathway, it can go in this red pathway, or it can go in the green pathway. This all depends on energy. It all depends on ATP. So the only time citrate should leave the mitochondria for it to become fatty acid. Fatty acid synthesis occurs in the cytoplasm, in the smooth endoplasmic reticulum. And to do that, you have to deliver citrate outside, convert it back to acetyl-CoA, and then combine it. We haven't talked about it yet. Okay. Now, whenever you have too much ATP, this process will occur. Less ATP, that means isocitrate will be converted to what? Alpha-ketoglutarate. So this enzyme, what was the enzyme from isocitrate to alpha-ketoglutarate?
Isocitrate dehydrogenase.
Very good. Isocitrate dehydrogenase. This enzyme is driven by what? By ATP. Too much ATP inhibits it. Okay. A lot of ATP will inhibit this enzyme. Okay. Less ATP. Okay. What is a used form of ATP? AMP. AMP or ADP. So too much ADP and AMP will activate it. Is it okay? Because once you produce NADH, this will be used for what? For ATP production. So this is a committing step. Whether you use glucose for energy or you store it permanently. That's what the significance of isocitrate dehydrogenase. Beyond that, nothing can leave for example, alpha-ketoglutarate and isocitrate, these guys cannot leave in its use of energy. Citrate can leave easily. Citrate this is a shuttle. So you technically are shuttling out acetyl-CoA into the cytoplasm in the form of citrate, and it's converted back to acetyl-CoA, and acetyl-CoA is used to make ATP. Fatty acid. So just know this for now. When you talk about fatty acid synthesis, it will make more sense. Okay. All fat are made of acetyl-CoA. So let's just say, once you take it to cytoplasm, it's converted back to who? Acetyl-CoA by citrate lyase. Okay. And then acetyl-CoA is combined 1, 2, 3, 4, 5, 6, 7, you get fatty acid out of it. So the enzyme isocitrate dehydrogenase is very important enzyme. It's energy driven. If you have too much ATP, because the enzyme is supposed to make what? ATP. If you have too much ATP, it says, oh, there's enough. Why should I make more? So it stops. It's inhibited by too much ATP. By lack of ATP, it is activated. Okay?
Are there any diseases related to isocitrate dehydrogenase?
No. Those things that are essential for life, yeah. Evolution was, I don't know if evolution was kind enough because it's random, but the creator was kind enough not to cause big issues like that. And if it is, you don't get to see those people. They don't live.
But when they call this acid to acid.
Yeah, I mean, as I said, there's crop cycle defects are very rare. Okay, that's why it's called a cycle. What's that guy who sings "Circle of Life" or something? You can think of crop cycle being the circle of metabolism or life, whatever. But anyhow, let me go over the hormones. Very important. We have only 30 minutes before we take the quiz. We talked about insulin, right? We didn't talk about it, but we mentioned insulin. We mentioned glucagon. And we mentioned cortisol. And we mentioned growth hormone. Poor thyroid hormone, I don't have room for it, but it's okay. There you go. Hormones. These hormones regulate things. Now, the part that you have to remember is their function for now. But I'll mention a lot more than that. Insulin is produced by pancreas. Insulin is made, produced, synthesized, stored by who? Pancreas. In pancreas there are the cells known as beta cells. Beta cells of pancreas produce what? Insulin. Beta cells of pancreas produce insulin. Glucagon is produced by the alpha cells of pancreas. So glucagon and insulin, they're both produced by the pancreas. The factory that produces insulin and glucagon are both pancreas. Whenever an organ produces two hormones and both of them has to do with sugar metabolism, they will have the opposite function. But for now, just know that insulin is made by the beta cell of pancreas, alpha cells of the pancreas makes glucagon. Are we good? Okay. Cortisol is produced by the adrenal cortex. Adrenal cortex, which is this gland sitting on top of the kidney. The cells that makes cortisol are not vesicular cells. Vesicular cells or cortisol producing cells. Layer is known as vesicular layer. Growth hormone is produced by who? Anterior pituitary. Anterior pituitary. And the cells that make, they're known as what? Somatotrophic. Somatotrophic cells. Thyroid hormone is made by who? Thyroid gland. Thyroid gland. What are the cells? Follicular cells. Follicular cells of the thyroid. Okay. So let me highlight the cells. Follicular cells of the thyroid makes thyroid hormone. Somatotrophic cells of the anterior pituitary makes growth hormone. Vesicular cells of the adrenal cortex makes what? Cortisol. Alpha cells of the pancreas makes what? Glucagon. Beta cells makes what? Insulin. Very good. And one more thing, guys. I know you guys know pancreas looks like this. Okay, so in the pancreas there are a cluster of cells. Here you go, cluster. Majority of the pancreas is not endocrine, it's exocrine. This cluster of cells, red being alpha cells. Okay, red being alpha cells and green being beta cells. And then there should be gamma cells and delta cells as well. Okay, it's a cluster of cells. Cluster here, cluster there, cluster. They're known as Langerhans cells or islets of Langerhans. If you look in pancreas, you think of pancreas being the ocean, and then these small, tiny little islands being Belize or whatever Caribbean islands. You know, they're known as islets of Langerhans. Islets of Langerhans. Islets means island. Of Langer, I think it's, is it pronounced Langer or Langer? Langerhans. I thought there's something like that. The guy who discovered it. If you guys discover something, you just give it your name. Okay? Islets of Langerhans. Islets of Langerhans means both alpha cells and beta cells both. Okay, it's a cluster of cells. Okay, so far we know about the location where these hormones are produced, but we don't know their action. Oh my god, it's so important. You know, these hormones are 3000% on your exam. 3000%. All the exam that you will be getting from now on until you quit practicing. Even when you wanna, for example, as an internist, as a physician, you wanna renew your license, you will still have questions on them. Okay, you can't ignore them. Okay, especially step 1. Oh my god, I love it. Now, insulin has only one function. Let's just keep it simple. It wants to store everything. Insulin loves storing. Insulin loves insulating things, wrapping around in those plastic bags, whatever, if that makes sense to you. Insulin loves insulating things, storing things, storing. So when we're talking about now about glucose, where do you store stuff? Outside the cell or inside the cell? So insulin promotes uptake of glucose by who? By cells. Through glutes, yeah. So insulin promotes uptake of glucose by cells. It increases glucose uptake by cells. Glucose uptake. So insulin promotes glucose uptake. So it promotes infusion of glucose into cells so you can store them. Not to use them, but to do what? To store them. And how do you store them? First as glycogen. So therefore insulin will promote what? Glycogen. If glycogen stores are full, then what? Fat. So insulin promotes fat synthesis. Yeah. Do you think insulin will increase the conversion of citrate to acetyl-CoA? Yeah. Yeah. Would it inhibit isocitrate dehydrogenase?
Yes.
Yes. It would inhibit isocitrate dehydrogenase. Definitely, for sure, 100%, guaranteed. That's what insulin will do. Okay, so insulin has one main function, and that main function is to store everything inside a cell. So it promotes uptake of glucose, it promotes uptake of amino acids, it promotes uptake of what? Fatty acid. It wants to store everything. Specifically, it loves uptake of glucose. Okay, so now let's talk about some processes. Process of, for example, storing glycogen is known as, glucose is known as glycogen synthesis. Glycogen synthesis. Okay, glycogen synthesis. I want to make some room for myself so I can do it in this way. Okay. So there are some processes. You know, what is glycogen synthesis? Glycogen synthesis. Making glycogen. What is glycogenolysis? Glycogenolysis. Very good. Okay. How about fatty acid synthesis? Okay. And then the opposite of that is known as beta oxidation of fatty acid. Beta oxidation. Once we know these processes, it will make sense. There's one more process known as gluconeogenesis. Gluconeogenesis. And then we have another process known as glycolysis. Okay. Glycolysis. Gluconeogenesis, glycogenolysis, glycolysis. And then we have protein synthesis, right? Protein synthesis. And then protein breakdown. Okay, so major sources of food. Look, as we discussed if you were to memorize one function of insulin, what are you going to think? It takes everything in. It starts with in, not even out. In, bring it in. So it increases uptake of everything by cells. That's what insulin does. Now, with insulin increased glycogen synthesis, yes, I'll put a plus sign, or if you like, arrow. Insulin increases glycogen synthesis because glycogen synthesis, making more glycogen, is storing sugar. So insulin promotes glycogen synthesis. How about glycolysis, glycogen lysis? No, that's inhibited. It's decreased by insulin. Do you like positive and negative signs or arrows? Okay. So glycogen lysis will be decreased, inhibited by insulin, because that's the opposite of glycogen synthesis. Making glycogen, breaking glycogen. Making glycogen, glycogen synthesis. Breaking glycogen, glycogen lysis. Okay, so if insulin wants to store sugar, you can't break it though. That's not that's the opposite of storing. Okay. Fatty acid. It will increase fatty acid synthesis. It will decrease fatty acid breakdown. Beta oxidation means fatty acid breakdown. Beta oxidation means fatty acid breakdown. Okay. What do you think? Very good. Why? No, not gluconeogenesis. Glycolysis. What's glycolysis? Converting glucose into pyruvate. Converting glucose into pyruvate. What happens afterwards is a different story. Glycolysis simply means converting glucose into pyruvate. If you have oxygen, then it's known as aerobic glycolysis, and it'll become what? Acetyl-CoA. If you don't have oxygen, it will become what? Lactic anaerobic glycolysis. So how would insulin affect? Oh, the next one is gluconeogenesis. I see what you were saying. I jumped. Sorry. Gluconeogenesis. What does gluconeogenesis mean? Making new glucose. And whenever you want to make new glucose, you cannot make it from existing glucose. That's not new. That's old. When you make glucose from lactic acid, when you make glucose from lipids, when you make glucose from amino acid or DNA, that's known as gluconeogenesis. Is that okay? Whenever you get glucose from a non-glucose source, it's known as gluconeogenesis. The major source is proteins, and the second one is lipids. Okay. So gluconeogenesis. Do you think insulin will increase gluconeogenesis?
Decrease
It should decrease it. Why is that?
because then we'll be breaking down fat and protein.
But let's do this. What is the purpose of gluconeogenesis?
Make more
Make glucose.
Only glucose. To make more glucose, new glucose. Why would you want to make new glucose? Because you don't have glucose from your diet. The only time, if you're getting glucose from your diet, you don't have to make it from scratch. It's almost like sugar sitting in your kitchen, and in my case, tomato shaped stuff, whatever, the little pot. It's tomato shaped. So if the sugar's sitting there, I'm not gonna go to Indiana, grow sugar canes, and then dry it out, and then sugar. I'm not gonna do that. If I have sugar available, I'm not gonna go through gluconeogenesis. Think of gluconeogenesis, converting sugar canes, fruit, and vegetables to what? Into sugar, to dry table sugar. That's too much. The only time I'll do that, if the factories that produce sugar shuts down and whatever, and I have no other option. So gluconeogenesis, you will only make glucose when you're hypoglycemic to begin with. Does it make sense? Okay. I mean, I shouldn't pick on Indiana. Wisconsin I can pick on, right? Okay, now, next thing. So insulin should not promote making new glucose, because its job is to store. If you need glucose, why would you want to store? So insulin can't do that. Insulin should inhibit gluconeogenesis. And how about glycolysis? Would it promote breaking down of glucose, insulin? Why?
No, I mean, it should decrease.
Okay, so everybody's saying decrease?
Um,
Is there anybody brave who says increase?
I want to.
Okay, then tell me.
Because you can still shunt that into making fatty acids.
That's all. That's all. See, insulin is not supposed to store glucose when you're low on glucose. It will only store when you have extra. Insulin, its job is to store. And when do you store things? When you have extra of it. When you need it for energy use, why would you want to store it? It makes no sense. Insulin is very smart. Unless you abuse insulin, spoil insulin, it won't do anything. It's us spoiling him. So insulin's natural job is to store. But if you have lack of energy, insulin will not be even produced in the first place. The purpose of insulin is to store extra glucose, not glucose that you need. It makes no sense. Never it would do that. Your body won't even produce insulin if you have need for glucose. It won't even produce that. So technically, glycolysis should be increased by insulin when? Because there's a lot of ATP. That means instead of glucose or acetyl-CoA going to isocitrate, it will go to outside of the mitochondria and become fatty acid. So insulin promotes fat synthesis, and that's how it does it. That's how it does. It decreases the production of isocitrate dehydrogenase. It promotes the production of citrate synthase and citrate lyase, for example. Maybe I'm speaking a different Pashto language right now, you don't get it. But understand this. Insulin simply promotes synthesis of lipids, synthesis of carbs, synthesis of proteins. It wants to store everything. It's anabolic hormone. It wants to build larger molecules from small. Never do the opposite. So we understood today that if you have too much glucose, it will be first used for energy. The extra glucose will be stored what? As glycogen, and eventually stored as lipids. So insulin will promote both of them. Insulin will promote both of them. So glycolysis will be increased by insulin. Not for the use of energy production, but to store glucose as what? As acetyl-CoA, eventually fatty acid. Okay. Yeah. Let me show you. Let me show you how. I know why this should be a confusing statement. We know that glucose becomes pyruvate, correct? Are you okay so far with that? And pyruvate, it becomes acetyl-CoA, right? Let's say acetyl-CoA. CoA. And acetyl-CoA will combine with oxaloacetate. That's the Krebs cycle. Oxaloacetate combined with acetyl-CoA will give you what? Citrate. Citrate can become two things. Either it becomes alpha-keto glutarate, or it leaves the mitochondria and it becomes what? Acetyl-CoA again in the cytoplasm. Insulin, one more way you can memorize insulin. Insulin is the hormone of high energy. Insulin is the hormone of high energy. When do you store things? When you have too much of it. Insulin likes to insulate, likes to store. The only time you would store if you have extra. The only time you will store if you have extra. If your life depends on whatever you have right now, you're going to use it. You're not going to store it. Let's say, you only have $100 in your pocket. Well, let's say you have $1 million in your pocket, and then you have to buy yourself a house, you have to buy yourself a car, your living depends on, you're going to use it, not store it in the bank. The only time you will store it if you have extra. So therefore, alpha-ketoglutarate conversion gives you ATP. Going through this pathway, you will get what? ATP. Going this pathway, you'll make what? Fatty acid. So what insulin does, it promotes glycolysis coming all the way up to here. And beyond that, it shunts everything this way. But it blocks this pathway. So it does not allow for citrate to become what? ATP. That's what insulin does. Why? Because that means the signal for that is increased ATP. Insulin will be only released. The pancreatic beta cells will only release insulin when you have too much ATP. When you have extra energy. If you have extra energy, your body is smart. When you have extra energy, what is it going to do with extra glucose? It's going to store it for later use. And to store it, number one, as glycogen, number two, as fatty acid. Okay? So that's what insulin does. Insulin wants to store, so it'll block the use of acetyl-CoA for ATP. It will shunt acetyl-CoA towards lipid synthesis. Okay.
Quick question.
Yeah.
Glycogen lysis to break down to use it right away versus to break it down to store it?
No, glycolysis, you can do two things. See, because the end product of glycolysis will enter where? The Krebs cycle. In the Krebs cycle, you can consume it. So let me do this. This is the Krebs cycle, okay? In acetyl-CoA, CoA enters the Krebs cycle, true? Krebs cycle can use acetyl-CoA to make ATP. It can use acetyl-CoA to make fatty acid. It can use it to make amino acids. Okay, alpha ketoglutarate can be converted to glutamate. Sounds the same, right? Okay, and then for example, citrate will be converted to acetyl-CoA or lipids. Now, if you have no energy, you have less ATP. How about this? Why am I drawing? The priority is ATP, step 1. If there's less ATP, this will not occur. These two will not occur. The product of Krebs cycle will be used primarily for what? For ATP. That's the priority. But if you have a lot of ATP, for example, I eat too much, 6 plates of rice and chicken and blah blah blah. Now you have enough ATP. What am I going to do with the extra acetyl-CoA? Shunt it this way, shunt it this way. Okay? But before that, before even that we reach here, there's glucose 6-phosphate. And this can be converted to glycogen. So insulin promotes all of them. It promotes this, promotes this, promotes this, but not this. Because the only way insulin can be released in the first place is what? When you have enough ATP. The signal for beta cells to make insulin is a lot of energy.
My question was more of the difference between those two. I know we studied it before, but it never sticks for me. So
Okay.
what's the difference between...
I'm going to put some glue on it right now.
Okay, good.
Yeah.
Glycolysis and...
Glycogen lysis shows
Yeah.
the difference.
Okay. Glycolysis and glycogen lysis, right? Yeah. Okay, good. So I'm going ahead of myself, but that's good. Some of you have to bear with me. So glycolysis, so we have glycogen. Glycogen, when you break glycogen into glucose, this is glycogen lysis. Okay, so this is glycogen lysis. Are we okay with that? Okay. Now, if you take glucose, break it down into pyruvate. Let me just say acetyl-CoA. You know what, just keep it simple so I know what you're talking about, so it relates to you. If you break it to acetyl-CoA, this is glycolysis, let's say. Make sense? Okay. The purpose of this is to increase blood glucose level. When you want to break down glycogen, liver glycogen, it only serves one purpose. To do what? To increase blood glucose level. Blood glucose, that's all. Its job is nothing else. Okay? If you already have, now if you have increased blood glucose level, let's say if you have increased blood glucose level, this is not going to occur. You don't need it. If your blood glucose level is already enough, it's high after eating, what happens to your blood glucose level after eating? All the glucose is reabsorbed from where? From the GI into blood. So blood glucose level is high. Now it will go through glycolysis to make ATP. If you have enough ATP, then acetyl-CoA is converted to fatty acid. Or first, glucose is stored as glycogen. So if you, this is the first, and then the second step or the third step is storing as fatty acid. So when you have insulin, you will not have glycogen lysis. You will only have glycogen synthesis. And if the glycogen stores are full, then you will store it as what? Fatty acid. Now glycolysis is not always for the production of ATP. It's also to store glucose permanently as lipids, not as sugar. Okay, so glycolysis, just because it's connected to Krebs cycle, Krebs cycle can store the same glucose permanently as lipids, or it could use it for ATP. It depends on you. If you're working out, if you're thinking, if you're exercising, it will do what? It will use it. If not, it will store it permanently. Does it answer your question? Okay. Now, you know, when we combine all the metabolism, there'll be an at the end of this week, not right now. Okay, so I know things might not make sense, but just focus on what I'm telling you right now. Protein synthesis. Insulin will increase protein synthesis and will decrease protein breakdown. Okay, because insulin wants to store amino acid in the form of protein, wants to store fatty acid in the form of triglyceride, wants to store glucose in the form of glycogen. Insulin, insulate, store. It will prevent breakdown of everything. The only reason it promotes breakdown of glucose, Nina, is to store it as something else, as lipids. Glycolysis, it promotes glycolysis to store glucose in the form of triglyceride. Otherwise, it won't do that. Okay? And the only time insulin will be released if you have too much glucose. When you have low glucose, glucagon will be released, the opposite hormone. Okay. Now, the function of glucagon is to decrease. Exactly. Everything opposite. Think of glucagon the opposite. But there's the thing, guys. The main function of glucagon is stress hormone, is when you're starving, when you're hungry, to restore blood glucose level. To do that, it has to break down glycogen. It has to break down lipids. It has to break down protein. So I'll tell you three things. Glucagon increases, where's glycogen and lysis? There you go. It increases glycogen lysis. It increases beta oxidation. It increases gluconeogenesis. What's the primary function of glucagon? One function, please memorize. Only to increase blood glucose level. Only to increase blood glucose level. Focus on what I'm telling you. The purpose of glucagon is not to make energy, not to do anything. It has only one function, to increase blood glucose level. Yeah.
Isn't it more correct, say, to maintain a specific glucose
Yeah.
normal?
So it will be only, exactly. That's fine. That's more correct. Okay. So the function of glucagon is only to increase blood glucose level when it's low. Okay. Not abnormally high. Just in the normal range. So when you have hypoglycemia, when you're hungry, see, when you're full, when you eat, insulin will be released. It will decrease blood glucose level. When you're hungry, glucagon will be released to increase blood glucose level. Okay. All right. But insulin not only acts on glucose, it acts on everything else. Okay. Insulin is a hormone of high energy state, fed state, not starving state. Starving state is who? Glucagon. But glucagon, look, glucagon can break down who? I'll say here, right now I'm going to erase these guys, but you can add to them. I want to make it simple so that you understand. Let's talk about carbs, protein, and lipids. Okay. Insulin wants to increase synthesis of carbs, increase synthesis of proteins, and increase synthesis of lipids. That's what insulin does. That's their job. Now when it comes to glucagon, glucagon simply has one function and only one function, and that is to increase or maintain blood glucose level or plasma glucose level. It's just to maintain plasma glucose level. Maintain blood glucose level.
From low to low.
Yeah, so you want to maintain it between, roughly speaking, 80 to 100 or 6 to 100, something like that, milligram. So, and how does it maintain it? It cannot decrease blood glucose level, it can only increase. Okay? So glucagon only increases blood glucose level. Okay, so that's why I should say it will only, its job is to increase blood glucose level when it's low. So what is the signal for the release of glucagon then?
Low blood sugar.
There you go. Glucose less than 60 or less than 80. That's all. Nothing else. When blood glucose level drops, glucagon is released. So beta cells responds to what? High blood glucose level. Beta cells are activated by who? When you have your blood glucose level is high. That's what activates beta cells. So they can release insulin and glucose. Alpha cells, they respond to low blood glucose level. So they will release glucagon in response to low blood glucose level to do what? To increase blood glucose level. Okay? I'm going to draw a line here. Insulin does the opposite of all of the rest of them. Insulin does the opposite of the rest of these guys. Okay? So let me come back to this. Let me come back to glucagon. What's the main function of glucagon? Increase blood glucose, period. But the priority is to break down glycogen into glucose. Okay, the main function of glucagon is what? To break down glycogen. So its job is glycogen lysis. That's the main priority. It will also act on lipids, will also act on proteins, but not so good. If I were to give you arrows for for entire knowledge in one day, so there will be some, you will have questions, trust me. Okay, but it will come with time. I'm simply telling the priority of glucagon. Glucagon has only one priority, to increase blood glucose level when it's low. That's all. How does it do it? It prefers to do it by breaking down who? Glycogen. Hepatic glycogen. Okay? It will also act on fat breakdown, but minimum on protein breakdown. Okay. So that's for glucagon. Now, let's move on to cortisol. Cortisol comes when blood glucose level is severely low, long-term low, when you're actually fasting, not between meals. Cortisol, now we said this one was carbs. You know what? I'm going to erase insulin because you know it. I just need this space, just to show you what we're talking about. I'm going to write here hepatic glycogen. Hepatic glycogen. Okay. And then I'll talk about muscle protein, because major source of protein is what? Muscle protein. Oh, that should have been, sorry, that should have been lipid. Okay, lipids is adipose tissue. Okay, so I'll put adipose tissue. And the form of lipid we're talking about is triglyceride. And then muscle protein. Glucagon prefers to break down hepatic glycogen, to break it down. Break down hepatic glycogen, okay? So it will be breakdown of hepatic glycogen. Breakdown hepatic glycogen. Why? To release glucose so you can restore blood glucose level. Okay? That's the first priority. Second, it will go to adipose tissue, will act on adipose tissue if it needs to. Okay? Protein, it really doesn't act much on protein, but yes, it'll break some protein, not a lot. Now, when you go to cortisol, cortisol acts on, for example, on glycogen. It breaks down glycogen, it breaks down adipose tissue, and it also breaks down muscle. Mainly muscles. See, cortisol is released when you don't have enough glycogen left. Released is glucagon. When glucagon fails to do its job or all glycogen are depleted, then who comes? Cortisol. Okay? Cortisol usually not even released in high concentration. Look, when I say release, I'm not saying it's not released, period. There's no such thing in physiology. High concentration of cortisol only comes into play when you're starving for 8 hours. Beyond 8 hours, cortisol is the primary hormone. Between meals, the primary hormone is who? Glucagon. So between meals, The primary hormone is glucagon. When you're starving, fasting, the primary hormone is cortisol. Okay. When you're working out or doing exercise, then it's growth hormone. Thyroid hormone, again, it's for metabolism. It's when your body needs energy in that sense. Okay. Yeah.
What if you're starving for like 8 or 10 hours and you are exercising?
Oh, then you have both growth hormone and cortisol, which is a great idea. I'll come to that. Keep that question, okay? Great idea. I don't think we can do the quiz today. I'll just send it to you. You can do it at home. It's just for your practice, okay? It's just for you to practice, and then Shukrullah can go over the answers tomorrow. Okay, look, growth hormone on the other hand, it breaks down hepatic glycogen, that's true, and it acts on lipids primarily, but it spares protein breakdown. It doesn't do protein breakdown, it inhibits it. You see the arrow is different in opposite direction. So we need to memorize the primary function of growth hormone is to break down what? Lipids. The primary function of cortisol is what? To break down muscles and protein. The primary function of glucagon is to break down glycogen. Hepatic glycogen, not muscle. So you got to know these priorities, then you can make sense out of it. Okay. Thyroid hormone simply increases metabolism, so it will start breaking down everything. It does everything evenly. Thyroid hormone. Okay. Muscles, lipids, and carbs. It does all three of them.
Doesn't that just regulate what's going on?
Yeah. All four of them regulate. Okay, so that's hormones. So please understand the priority. Now, if I ask a question, is gluconeogenesis inhibited by cortisol or activated? You should know the answer.
Sorry, so thyroid hormone just does on everything?
Yeah. It breaks down everything.
Okay, so when is it produced? Is it just a constant?
It's for metabolism. It maintains your basal metabolic rate.
Oh, so homeostasis.
Yeah. Okay, so let's see this glucose. The major function of glucose, so plasma glucose. When the glucose is high, when the glucose is very high, then insulin is produced, because insulin is what?
Decrease.
Insulin is supposed to,
Decrease concentration.
yeah, store it. Insulin. Insulin is released when you have high blood glucose level. It's supposed to store glucose. Now, when you have low glucose, first hormone is glucagon. Okay. Second hormone is growth hormone. Third hormone, last one is cortisol. Okay. Level. High blood glucose level increases insulin. Okay. The job of insulin is to decrease blood glucose level. So when do you think your body should produce insulin? When you have too much glucose in the blood. Why? Because insulin can decrease it. Make sense? Very good. Now the function of all of these guys is to increase blood glucose level. Blood glucose level. So when would they be released or produced by your body? When your blood glucose level is low. So insulin should be produced when your blood glucose level is above 100. Glucagon in these guys should be released when your blood glucose level is less than
60.
I should say 80. Let's just say 70, 80. Okay, so when it's low. Now, the first one is glucagon. Glucagon prefers to break down the temporary stores first. Cortisol wants to break down permanent stores. Growth hormone is the best option if you can do, but growth hormone production is induced by activity, exercise, mental and physical activity. So if you want to purely get rid of fat, you have to stimulate production of growth hormone. Growth hormone. Now growth hormone does two things. It builds muscle, so it prevents breakdown of proteins, and it induces selectively to break down fat. So that's why you know, exercise is a big deal. Not only physical, mental as well, both. Mental. Okay? So know the priority of these hormones. If you have questions, you can ask me later. What was the other things? Vitamin B1, you said?
B1.
Let's talk about vitamin B1. For now, at least for now, vitamin B1 is required by pyruvate dehydrogenase. Pyruvate dehydrogenase requires vitamin B1. Okay? Vitamins are coenzyme or cofactors. They are required for efficient function. It's not good enough. Or 60%. It's not 100%, at least for sure. So B1 is required by who? Pyruvate dehydrogenase. And you should know that pyruvate dehydrogenase is known as pyruvate dehydrogenase complex. It has pyruvate decarboxylase, one component, and then coenzyme A, and then B1. It's a complex of multiple things. Yeah, pyruvate dehydrogenase. It's a complex of enzymes. So this enzyme requires coenzyme A, which is nothing more than carrier of what? Pyruvate, because acetyl-CoA. The coenzyme A, if you remove, what does pyruvate look like? It's a 3-carbon sugar, right? Okay, so something like this. When you remove the OO at this point, the two O's, it removes carbon dioxide, and instead it adds to it as the coenzyme A. It becomes acetyl-CoA. But anyways, we don't care for that. Just for it to make sense. Coenzyme is a coenzyme. It's not a true enzyme. It helps the enzyme. Okay, so it carries the acetyl group. B1 helps this reaction, and then we have nicotinic adenine diamide, nicotinic acid diamide, which is NAD. It's also required. So that's a cofactor as well. NAD+. So these are the things that are required by who? By pyruvate dehydrogenase, plus oxygen. It's a huge enzyme. Without it, life is not possible. There's no such thing as clean pyruvate mutation, pyruvate dehydrogenase. There's no complete deficiency of pyruvate dehydrogenase because it's not compatible with life. Okay, so the most important thing is B1 deficiency. Pyruvate dehydrogenase is mostly affected by what? B1 deficiency. B1 deficiency. So that's why I'm talking about vitamin B1. So number one, pyruvate dehydrogenase requires it. The next one is isocitrate dehydrogenase. Also requires B1. Yeah. Yeah, lipoic acid is mostly by citrate synthase. Yeah. Okay. Okay. So this is required deficient in B1. That's one. Let me put this for you. Homeless. That's one. And the other one is alcohol. Alcoholics. Alcohol prevents absorption of B1 in the intestine. Alcohol prevents absorption of vitamin B1 in the intestine. It's almost like coating something and nothing can pass through. That's what alcohol does. It prevents absorption of B1. So homeless alcoholics, that's 2 double risk. Always the question would say that. Okay. Now B1 deficiency leads to partial activity of, decreased activity of pyruvate dehydrogenase and isocitrate dehydrogenase and transketolase and alpha ketoglutarate dehydrogenase. The end result is what? Pyruvate dehydrogenase is required for what? ATP production, right? It's required for ATP synthesis. So overall ATP production is affected, especially where? In the nervous system, because neurons depends on glucose metabolism the most. Lipids don't need pyruvate dehydrogenase. Amino acid don't need pyruvate dehydrogenase. Only glucose needs pyruvate dehydrogenase. So as a result, there are a couple of conditions that can come from B1 deficiency. Okay, it's known as Wernicke Wernicke's disease, and then Korsakoff. You can combine it to call it Wernicke-Korsakoff encephalopathy. Okay, Wernicke will lead to mostly cranial nerve neuropathies. You have 12 cranial nerves. They're primarily affected by the cranial nerve neuropathies. But also it leads to something known as dilated cardiomyopathy. So neurological symptoms and cardiac symptoms or conditions or disease. And this can be known as beriberi syndrome or disease. Yeah. When it includes heart, it's known as wet beriberi because there's CHF involved, congestive heart failure. But for now, just know B1 deficiency is a big deal, at least in our society. A lot of alcoholics will have this problem. And then now you know why alcoholics tends to lose memory, become amnesic. Why? Because there's not enough energy going to hippocampus, mammillary bodies of the CNS will learn that anyways. So as a result, they deteriorate, they die, the neurons die, and it's irreversible. See, damage to neurons by alcohol, if it's long term, when it reaches this level, it's irreversible. There's no way recovering from that. Neurons cannot regenerate, especially in the CNS. They don't have the ability to regenerate. So it affects your mentality, your mood, the way you think, a lot of those things. Okay? So B1 is a big deal. But again, not everybody. We're talking about alcoholics, not social drinkers. There is no evidence that social drinkers will suffer a lot, but yeah, they're still affected. Okay. Alright, so that was for B1. What else? That's it, right? Okay.
No, O2, NAD,
NADH, remember, is just a carrier. So the enzyme that depends on NAD, oh, there's two things. Once we have glucose, this will be the last thing for today. Glucose can become pyruvate. Again, many steps for now. You gotta memorize those steps. And this can become acetyl-CoA or can become lactate or lactic acid. Okay. Very good. Now, pyruvate dehydrogenase is one enzyme. Lactic dehydrogenase is another enzyme. Lactic dehydrogenase depend on lack of oxygen. Lactate, lack of oxygen. Pyruvate providing oxygen. Give me oxygen. It depends on it. Now this guy produces NADH. Okay? This guy produces NAD+. So pyruvate dehydrogenase needs NAD. I'll use green for that. It needs NAD+. Lactate dehydrogenase need NADH. They're opposite in every sense. Okay, they're opposite in every sense. I'll ask you a question on the exam. If you have no oxygen, right? There's no oxygen. This reaction will not occur. True? So let's just break it. This doesn't occur. Almost all of your glucose goes for a few minutes. You can survive 2-3 minutes. It goes in this way. Why is lactate dehydrogenase prolonging life? Short term. Find out for me.
because NADH needs to get recycled into NAD, otherwise this process stops.
Good. What he's saying is there is glycerolaldehyde, 3-phosphate, which requires NAD. Yeah. This is the only way you can produce NAD. Yeah, that's true. There you go. Good job. He helped them. They were supposed to do some homework. Oh, wasn't there homework?